Nice launch trajectory countdown. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
On your screen is a live view of Falcon 9 awaiting its 6:16 a.m. Pacific Time launch from Slick 4 East at the Vandenberg Space Force Base in California. Good morning, everyone. My name is Shiva, and I'm a space operations engineer here at SpaceX. Thanks for joining us for the Iridium OneWeb mission, which marks our 33rd mission this year and our 232nd overall mission to date. Now, if you've been following along, you'll know we had an abort yesterday at the T-minus 55-second mark during our launch attempt. But since then, the teams have completed checkouts on the vehicle and the ground systems, and we're looking good going into today's T0 at just about 15 minutes from now. Now, we are flying two primary customers on today's mission, Iridium and OneWeb. Combined, they are going to be sending a total of 21 spacecraft into low Earth orbit, or LEO. Iridium is sending up 5 upgraded spare satellites, and OneWeb is sending up 16 satellites, including a demonstration satellite, into space today. Now, all of the 21 spacecraft will deploy during 2 separate deployment sequences after our second stage performs 2 burns. It's likely we won't have live video coverage of that first deployment sequence, but we will have telemetry for the first 6 deployment events, and that'll allow us to confirm successful deployment over the nets. Now, those last 2 deployment events in the first sequence will happen during a blackout period, so we'll confirm those a few minutes later when we regain telemetry. We're going to have more about the customers and their payloads a little bit later on in the webcast, and if you're interested in following the full deployment schedule, check it out at spacex.com. Now, we're just about T-minus 13 minutes to go. Despite how it looks, the weather is actually fantastic for a launch today. The range and vehicle are also tracking go to launch, and we're tracking no issues with the customer payloads. Now, on your screen is, in fact, a live view of the Falcon 9 rocket. You can see a little better view of it there. Falcon 9 is a 2-stage rocket. It's about 230 feet tall, and when it's fully loaded with propellants, it'll have about 1 million pounds on board. We actually began loading those propellants at around the T-minus 35-minute mark and began liquid oxygen loading actually just as the webcast went live. Now, starting at the very top of the rocket, we've got our payload fairing. That's that nose cone structure you can see at the very tip of your screen. And that is what is containing our 21 satellites today. The payload fairing protects the payloads from aerodynamic heating, loads, and contamination during the ascent phase of the mission. But once we get to the vacuum of space, we don't need it anymore. So we jettison those halves back while the second stage continues on to orbit. It's in shadow there behind Vandenberg's famous fog, but you can sort of see it on the right of your screen. Now, it is worth noting that we're going to have 2 deployment sequences during today's mission. The first deployment sequence will deploy all 5 of the Iridium satellites and the first 6 OneWeb satellites. And then the second will deploy the additional 10 OneWeb satellites that are on the mission. Now, below the payload fairing, you can see sort of a white structure and then a black structure there on your screen. That white structure is the second stage. And in the black structure, which is our inner stage, is the Merlin vacuum or MVAC engine. The second stage is what's going to carry the 21 spacecraft into low Earth orbit to their payload deployment. Now, the Merlin vacuum we're flying on today's on today's mission has a shortened nozzle. We're going to get a much better look at that during the burns and during stage separation. The shortened nozzle made its debut on the Transporter 7 mission, and it'll continue to be used on missions that don't need quite as much performance to get to their final destination. Now, as a reminder for really all you MVAC fans out there, the large nozzles, the regular size nozzles on MVACs aren't going away. We still fly them on missions that require more thrust, or more efficiency to get heavier payloads into orbit. Now, moving down, we've got the bottom 2/3 of the rocket, which is referred to as the first stage. We also refer to that as the booster. At the very bottom of the first stage are the 9 Merlin engines, M1D engines, that will take Falcon 9 off the ground from the launch pad and put us outside of the thicker parts of the Earth's atmosphere. Now, shortly after liftoff, we'll expect the stages to separate from one another. The second stage will take the payloads into orbit, while the first stage makes its way back to planet Earth for recovery. It is designed to be reflown with minimal refurbishment in between flights. In fact, this particular first stage has flown, or will be flying, I should say, for its 11th time, has flown 10 times, and will attempt a landing on our drone ship named, of course, I Still Love You. That's stationed in the Pacific Ocean, downrange about 650 kilometers. Now, if we're successful, that landing will mark the 193rd recovery of an orbital class rocket. I mentioned it a little bit earlier, but we're flying 2 customers on today's mission, Iridium and OneWeb. Iridium is a global satellite communications company. They provide access to voice and data services anywhere on planet Earth. If you've been watching SpaceX a long time, you'll know that we flew 8 launches for Iridium that finished up in 2019. But here, 4 years later, we're happy to be working with them again to send another 5 upgraded spare satellites into space. These satellites will further Iridium's constellation's resiliency, bringing their total number of spares to 14 and the total number of satellites in orbit to 80. Now with that, let's learn a little bit more about Iridium and what they're flying today.
Innovation, versatility, safety, resilience. These are just a few of the words that represent Iridium. Millions of people know they can trust Iridium to connect them to and from anywhere on the planet every day. As a result, when family, friends, and colleagues venture off the grid, including to the world's most dangerous environments, they choose to stay connected with Iridium. And some are researching climate change, combating poaching, cleaning plastic from the oceans, and ensuring critical aid can be safely delivered to those in need. This is what Iridium was made for. Most important, Iridium is a lifeline for those in dire situations, and it remains the only satellite network that lets you send out an SOS from anywhere on Earth. We take this responsibility and the trust placed in Iridium very seriously. Our upgraded satellite constellation, packed with redundancy in space and on the ground, is a testament to our unwavering commitment to those relying on us today and the millions more to come in the years ahead. The original Iridium satellite constellation lasted over 20 years, well beyond what was expected. We designed our latest constellation to even higher standards with even more flexibility. That's why today, you can expect Iridium to continue delivering the highest quality service in any weather condition across the whole planet well into the next decade and beyond. Quite simply, there is no network like Iridium.
Now we've got 2 main customers on today's mission, and OneWeb is that other main customer. Today's launch marks OneWeb's 19th overall launch and our 4th launch with SpaceX. Once the 16 OneWeb satellites on board the second stage deploy, it'll bring OneWeb's constellation to 634 satellites in total. Among those 16 satellites, there's also a special demo satellite called JoeySat, which is going to test an innovative beam hopping capability, allowing the satellites to switch direction and signal strength based on customer needs or demands. Let's take a quick look at OneWeb and the payloads that we're flying today.
Think for a moment about what connectivity brings you. Is it helping you manage or grow a business, stay in contact with family and friends? Is it giving you or your family access to education or to a doctor? Is it opening doors for you to a world beyond your horizon? Of course, for many of us in big cities and large and established communities, it's doing that every day. It's essential, fundamental, it's enabling our lives. From connectivity flows a better quality of life, new horizons and greater opportunities. So what can we do to help ensure everybody can experience the benefits of connectivity? This is the OneWeb mission, to bridge that digital divide, to serve businesses and rural communities, to further scientific understanding and collaboration. And we're doing this by bringing high-speed broadband internet from space to places where this opportunity was previously unimaginable. Every customer connected via the OneWeb network has their own story. All of them are united by one thing: gaining the power of connectivity and the independence or sense of community that can bring.
OneWeb Launch 19 with SpaceX will fly 15 satellites into our LEO constellation. In addition, a 16th satellite will be included that we have called JoeySat. JoeySat is a demonstration satellite which incorporates several features sets to be included in OneWeb's next generation constellation, including beam hopping technology, hence the name Joey. This satellite has been developed alongside our partners at SatixFy through our Sunrise program funded by the European Space Agency and the UK Space Agency. We can't wait to see it in space. Go OneWeb.
Now we're just about T-minus 4.5 minutes to go to liftoff. Coming up, we should expect to see the clamp arms open on the transporter erector. You can barely make them out there on the right-hand side of your screen. Now, the transporter erector is, of course, the structure that would be to the right of Falcon 9, kind of obscured by the fog here. It brought Falcon 9 to the vertical launch position and also routes electrical connections, communications, and, of course, propellants into the stages. And once we get down to T-minus 0, we'll expect the transporter erector to retract away using hydraulics at its base. And we've actually begun retracting away the strong back, which is another name we use to refer to the transporter erector. Maybe we'll get a glimpse of it here as from between the condensation and the fog. But the transporter erector is to the right of the vehicle, I promise. Now, the first stage is connected to the transporter erector at a launch mount at its base. And when we get to T-minus 0, that'll retract away fully, clearing the way for Falcon 9's launch.
Stage 1, lock flow complete.
There's a call out for liquid oxygen loading complete on the first stage. We're expecting a similar call out here on the second stage around the T-minus 2 minute mark. Falcon 9 uses two types of propellant, a fuel and an oxidizer. The fuel the fuel we use is rocket propellant 1, which is a refined form of kerosene. The oxidizer is liquid oxygen. And that's because we need an oxidizer to burn that fuel. And where we're going to the vacuum of space, we need to carry that oxidizer with us. When we're fully loaded with propellants, we'll have about 1 million pounds of both RP1 and liquid oxygen on board to feed the Merlin 1D and Merlin vacuum engines on the first and second stages, respectively. Should be coming up pretty close to liquid oxygen loading complete. You can see a little bit of the venting.
Stage 2, lock flow complete.
There's the call out there for LOX load complete. You can see a little bit of the venting, or bleeds, I should say, coming off of the second stage. And we should expect to see some venting here. You can barely make it out, and you can really hear it there. The transporter erector lines are being cleared out. I'm producing those clouds around the vehicle. Now, coming up next major milestone is at T-minus 60 seconds. That's when Falcon 9 transitions into startup, and the flight computers on board the vehicle will have control autonomously through the rest of the count.
Falcon 9 is in startup.
So from here, Falcon 9 has autonomous control of the rest of the count. The LD will give their final go for launch.
LD is go for launch.
Now the payloads continue to look healthy. Next major milestone coming up at T-minus 2 seconds when we ignite those Merlin 1D engines, and then liftoff at T0. We're about 30 seconds away.
T-minus 30 seconds.
Range and weather continuing to look good. Let's watch.
$15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Full power. Liftoff of Iridium OneWeb. Vehicle's pitching downrange. M1D chamber pressure is nominal.
Successful liftoff of Falcon 9 from Space Launch Complex 4 East at the Vandenberg Space Force Base. We're carrying the Iridium OneWeb satellites into orbit. We've begun gimbaling the engines on the first stage. Gimbaling is really just tilting the engines.
Telemetry nominal.
We've begun what's called a gravity turn. So we're letting gravity help pull the rocket to go sideways. We need to be going fast horizontally to get into orbit. We actually just got through the throttle bucket.
Vehicle supersonic.
Throttle bucket being where we've throttled down the Merlin 1D engines in preparation for max Q. That's the point of highest stresses on the vehicle.
Max Q.
Fantastic views from this ground tracking cam. Nice to be out of the Vandenberg fog. Now, a rocket needs to go about 17,500 miles an hour horizontally in order to avoid being pulled back down to Earth. And if it does get to that velocity, that's what we say, that's what we mean when we say we're getting to orbit. So we're continuing to accelerate on the first stage. Call out there of MVAC chill. And that's for the next several events we've got coming up. The first of those is main engine cutoff, where we'll shut down these 9 Merlin 1D engines on the first stage. That'll be followed by stage separation, where the first and second stages will separate from each other. The Merlin vacuum on the second stage will ignite at SES-1. And then we will have the fairing halves separate shortly after that around the T+3 minute mark. So again, those events back to back: MECO, stage sep, SES-1, and then shortly after, fairing separation.
MECO.
Stage separation confirmed.
MVAC ignition.
And there are great views of that shortened MVAC nozzle. Right-hand side of your screen is the second stage. Left-hand side of your screen is the first stage. We've begun deploying the hypersonic grid fins on the first stage. Those are those structures that are popping into view right now. Next major milestone will be a fairing deployment. If you keep a close eye out, you might even see those fairings behind the second stage as they trail away.
Fairing separation confirmed.
And there is successful separation of the fairings. Now both the fairing halves, in fact, there's a view of one of the fairing halves on the right-hand side of your screen, making its way back to Earth. Both of these fairing halves are flight proven, one of them having flown 3 times and the other one for its 6th time. And we will be attempting to recover both halves once they make it back to Earth using our recovery vessel named Go Beyond. T+4 minutes. If you're joining us, welcome. You're looking at a live view of Falcon 9. Right-hand side of your screen is the second stage in the first of 2 planned Merlin vacuum engine burns. This burn will last about another 4 minutes on the second stage. It's carrying our 21 payload satellites into orbit. On the left-hand side of your screen, we've got Falcon 9's first stage. Those periodic white bursts that you're seeing are actually from our attitude control system. We're reorienting the first stage to get the engines pointing down back towards the atmosphere, because we're coming up on Falcon 9 first stage's next major milestone as well.
Both vehicles are following nominal trajectories.
Call it there indicating that we are on the path we intend to be on. Now, the first stage is pointing its engines down in preparation for the entry burn. Entry burn is where we relight 3 of the Merlin 1D engines on the first stage. We relight the center engine and then 2 of the radial engines. And that maneuver is to slow down the first stage. We've picked up quite a bit of velocity in lofting the second stage and getting it started on its path to orbit. And we're going to bleed off a lot of that energy as we come back through the thicker parts of the Earth's atmosphere. So rather than taking all of that heat loading and structural loading directly on the vehicle, we use some of our propellant to slow down a bit. And that's what the purpose of the entry burn is. Helps us reduce the stresses and loads on the vehicle to help recover it. View from the inner stage. Just a few minutes ago, we had a second stage in there. Now, all the soot that you see actually comes from a couple of different sources. The soot that we're seeing in the inner stage came a little bit from that second stage burn. The soot that you see on the rocket actually comes from the entry burn primarily. We're flying quickly backward through our Merlin exhaust plumes, and we use a carbon-based fuel. So as we combust that, that leaves a nice small layer of soot on the vehicle. And reusability is really what makes the cost of spaceflight lower and enables more scientific research and infrastructure development in low Earth orbit like we're doing today.
Stage 1, FTS was saved.
Stage 1, entry burn startup.
There is startup of the entry burn. This should be a pretty short burn. Falcon 9 making its entry burn for its 11th time, this particular booster having flown 11 missions. Total burn duration, just about 20 seconds on the first stage.
Stage 1, entry burn shutdown.
And then followed by a little bit of attitude gas there just to get us pointed in the re-entry attitude that we want to be in. Now, from there on, the first stage actually has those 4 grid fins.
Nominal trajectories.
And as we get into the thicker atmosphere, we get more control off of those grid fins. They'll actually do most of the pointing. We don't need to use attitude gas or the engines to do that until the landing burn starts in just about 40 seconds. Now, the landing burn will coincide with second engine cutoff on the
Stage 1, transonic.
second stage. Second engine cutoff expected around T plus 8 minutes, 45-ish seconds.
Stage 2, FTS was saved.
Stage 2, terminal guidance.
Now, during the landing burn, we light just a single center Merlin engine, followed shortly after by landing leg deploy, and then hopefully a soft touchdown on the drone ship.
Stage 1, landing burn.
Pretty fun coming in through the clouds here off the California coast.
Stage 1, landing leg deploy.
MVAC shutdown.
Stage 1, landing is confirmed.
Okay, a lot of things happened there. But I see a successful landing
Nominal orbit insertion.
of our Falcon 9 first stage. We had a second engine cutoff there. You heard the call out for nominal orbital insertion. So we're in our first parking orbit for the second stage. And on the first stage, that marked the 193rd recovery of an orbital class rocket, including first stage landings for both Falcon 9 and Heavy. Now, of course, the mission isn't over yet. We've just done the first part. The second stage is embarking on its first coast phase. After this coast phase, we're going to relight that Merlin vacuum engine for a second time. That'll be around the T plus 55-minute mark.
Expected loss of signal, Vandenberg.
So we're going to leave you with some views and some space tunes. And we'll see you back here in about 45 minutes for our second engine start number 2.
Acquisition of signal, Easter Island. detected loss of signal, Easter Island. Acquisition of signal, Queen Maud Land, Antarctica. Expected loss of signal, Antarctica. Acquisition of signal, Hartebeeststock, South Africa.
Precisely the kind of information you want from the satellite.
Welcome back to the webcast for the Iridium OneWeb mission. Now, we've had a great mission so far. We had an on-time liftoff at 6:16 a.m. Pacific time from Slick 4 East in the Vandenberg Space Force Base in California. You're looking at a live view of the second stage on orbit as it's preparing for its second planned MVAC burn. Up to this point, we had a successful ascent and a successful orbital insertion on the second stage, and we also recovered our first stage, marking its 11th landing. And we're coming up just about 10 seconds away from a second ignition of the Merlin vacuum engine to put the Iridium OneWeb payloads into the payload deploy orbit.
Acquisition of signal, Malindi, East Africa.
MVAC ignition. MVAC shutdown.
And there was a successful burn of the second stage engine. Super fast burn, just a couple of seconds.
Nominal orbit insertion.
And with that call out there, operators confirming that we are in the intended payload deployment orbit. Just a little bit of orbital mechanics. That initial burn that we did about 45 minutes ago was the orbit insertion burn. That put us into what's called an elliptical orbit. An elliptical orbit, there's a high point, which is referred to as the apogee, the highest point around Earth, and a low point, or the perigee. And those 2 points are different on an ellipse. This last burn actually put us into a circular orbit, roughly 620 kilometers above the Earth's surface, for payload deployment. And you can actually see a couple of those payloads on your screen. We're looking at a couple of the OneWeb satellites and a view of planet Earth at the top of the second stage. Now, if you burn along your direction of travel, it turns out via orbital mechanics and the physics that'll raise the opposite side of the ellipse that you're on. And if you notice, we're at about 630 kilometers in altitude right now. So the burn we just took raised the lowest point of our orbit into the circle. And of course, at this point in the mission, we've actually consumed a fair amount of propellant on the second stage. So Merlin Vacuum's thrust is able to give us most of the acceleration we needed to hit the desired orbital energy pretty quickly, hence that super short burn. As a reminder, the 21 Iridium and OneWeb satellites are still attached to Falcon 9 second stage. In fact, we're getting some great views of them. And we're coming up on the first payload deployment sequence at T plus about 59 minutes, so just about 2 minutes away from now. This first deployment sequence is going to have 8 deployment events, consisting of deployment of all 5 of the Iridium satellites that we're flying today, and the first 6 of 16 of the OneWeb satellites that we're flying. Now, we're not sure if we're going to have video coverage of the first deployment sequence, but we are expecting to have telemetry, the data, for at least the first 6 of 8 events. And that data will allow us to confirm deployment on the nets. So an operator will be reviewing...
Expected loss of signal, hard at B-stock.
An operator will be reviewing the telemetry and confirming satellite deployments as we get that. The last 2 events are expected to occur during a data blackout period, and so we'll have to confirm those deployments a few minutes later when we regain ground station coverage. So again, about a minute from now, keep your ears open for those callouts of payload deployment. We'll be starting with the Iridium satellites and then moving on to the OneWeb satellites. Now, as a reminder, Iridium is a global satellite communications company. They provide access to voice and data services anywhere on Earth. After completing a series of 8 launches with us back in 2019, we're excited to be working with them again to launch 5 upgraded spare satellites on today's mission. Now, these additional satellites are going to further their constellation's resiliency, bringing the total number of spare satellites in orbit to 14 and their total number of satellites to 80. We're going to be starting with payload deploy just a few seconds from now.
Iridium 5, separation confirmed.
So with that call out there, the first Iridium satellite is away. Now, the operators on console are taking a look at a variety of data inputs to understand whether the payload has separated or not. You can typically see a little bit of acceleration on the vehicle from a payload deployment. They also typically have what are called break wires. They are essentially connections that when the satellite leaves, sends a signal that we can interpret in data to show that the satellite has deployed. And then we do have cameras on the top of the second stage. So if there is a question about the deployment, we can usually download the data later and review that data to see if we got a visual confirmation of deployment. Unfortunately, just the way the telemetry is working out right now, we don't have live views to provide you. If you're just joining us, we're off the east coast of Africa. We're in the middle of our first payload deployment sequence. Don't have great telemetry for video, but we do have telemetry of data to confirm these payload deployments. We're in the first batch of 8 deployment events in this first sequence, starting with the 5 Iridium spare satellites that we're flying today, and then followed shortly after by 6 OneWeb satellites. Iridium and OneWeb both being our customers on today's mission.
Iridium 4, separation confirmed.
And there's confirmation of the second Iridium satellite having deployed, so 3 more attached to the top of the second stage. Satellites typically fly on a payload adapter, which is at the top of the second stage. During ascent, that payload adapter was covered by the fairing to protect the payloads. We separated those halves. And now we're at the point where we get to deploy these payloads for the rest of their mission.
Iridium 3, separation confirmed.
So 3 out of 5 Iridium satellites successfully deployed. 2 more to go. And you may notice today that we are flying north across the coast of Africa. We flew in a polar orbit out of Vandenberg.
Iridium 2, separation confirmed.
So we flew out of a polar orbit out of Vandenberg. A polar orbit is exactly what it sounds like. It basically means we fly in a trajectory where the stage and then the payloads are flying pole to pole, perpendicular to the spin of the planet. Some satellites need to fly in polar orbits so that they can get coverage all across the globe. As they orbit the planet rotates under them, and they can get coverage of different parts of the world. And the Iridium constellation operates that way. So just about 40 seconds ago, we heard successful deployment of 4 out of the 5 Iridium satellites that were flying on today's mission. And their satellites are actually pretty large. They're about the size of a small car. So each of these satellites is going to be continuing on to their operational orbits. These ones are spare satellites to supplement the constellation that is already in orbit and offering services across the globe.
Iridium 1, separation confirmed.
And great news there. We've had successful deployment of all 5 of the Iridium satellites that were flying on today's mission. Coming up next, we've got the first of 3 deployment events scheduled for OneWeb in this first deployment sequence. Once we do deploy all 16 of the OneWeb satellites that we're flying, that's going to bring OneWeb's constellation up to 634 satellites in total. And among these 16 satellites, OneWeb is also flying a demonstration satellite named JoeySat to test an innovative beam hopping capability that'll allow them to their satellites to switch the direction and signal strength based on where customers need connectivity. We're just a few seconds away from the first planned OneWeb deployment event.
OneWeb Alpha 2 and Alpha 6, separation confirmed.
Great news there. First of the OneWeb deployment events is complete and successful. And we are expecting these next 2 events to happen during a period of LOS, or loss of signal. And that's where we would expect to not have live data, which will slow down that separation confirmation until we can get signal a few minutes from now. So we're going to confirm these deployments in a few minutes when we do regain telemetry. But that does confirm 6 successful deployment events, and 7 of the 21 satellites have successfully deployed. It does wrap up our coverage for Iridium, but don't go away. There's still 14 more OneWeb satellites to deploy for during this blackout period.
OneWeb Alpha 1 and Alpha 5, separation confirmed.
Oh, and it looks like we do actually have reasonable ground station coverage.
Expected loss of signal, Melendi.
And there's the LOS. Looks like we managed to get a little bit of additional signal. So that last OneWeb deployment we'll expect to get back when we get coverage a few minutes from now. as we get over the North Pole. Now, there is a second set of deployment events happening around the T+1 hour and 21-minute mark, so don't go away. We've still got, I think, 12 OneWeb satellites on board. For now, we're going to leave you with any views we might get and some space tunes. But we'll see you back here in about 10 minutes when we're expected to regain ground station coverage to confirm the last payload deployment from this first set. See you soon. Welcome back to the Iridium OneWeb mission webcast. Now, we just went through a loss of signal period where we didn't have any data coverage to confirm the last deployment event from the first deployment sequence. We're expecting to regain telemetry shortly here as we pass into coverage from the Svalbard station. And then we should be able to hear confirmation of the last deployment event.
OneWeb Bravo 8 and Bravo 4 separation confirmed.
And fantastic news, that confirms deployment of all 11 of the spacecraft from the first deployment sequence. The mission isn't over yet, though.
Acquisition of signal, Svalbard.
We do have one more deployment sequence, which is set to begin in about 5 minutes. We are hoping to have live views for those deployments of the remaining OneWeb satellites. So stay tuned. We'll see you back here in just a few minutes, around T+121, for the second payload deployment sequence. See you soon. Welcome back to the Iridium OneWeb mission webcast. Now, if you're just joining us, we've had a really great mission so far. We lifted off on time, 6:16 a.m. from Vandenberg Space Force Base. We had a successful first stage landing, 2 successful second stage burns, and successful deployment of all 11 spacecraft from the first deployment sequence. We're coming up on the second deployment sequence of 10 additional OneWeb satellites, including their demonstration satellite named JoeySat. We've actually got some great views of the payload adapter with those OneWeb satellites.
OneWeb Alpha 3 and Alpha 7 separation confirmed.
And there is both mission control and visual confirmation of OneWeb satellite deployment. We may be able to see it here in a minute. You might have noticed from the views that the second stage has a slight rotation that's intended to help with the payload separation and help the satellites separate from each other as they deploy. It's a pretty slow rotation rate. It amount to the stage completing a full rotation about every 6 minutes. And we've got some great views of the payload adapter and the OneWeb satellites set up in a ring around the top of the payload adapter. Now, at this point, we still have 8 remaining OneWeb satellites on board Falcon 9's second stage. We flew a total of 16 OneWeb satellites today, along with the 5 Iridium satellites that we deployed earlier during the first deployment sequence. And in that first deployment sequence, we deployed 6 of the 16 OneWeb satellites.
OneWeb Bravo 5 and Bravo 1 JoeySat separation confirmed.
And there is confirmation of the next 2 satellites, including OneWeb's demonstration satellite. Now, OneWeb satellites also operate in a polar orbit, meaning they fly around the poles of planet Earth as the Earth rotates below. Each of these satellites will see a different part of the globe and be able to provide connectivity services. And that just means a different set of ground stations for us, trying to line up our payload deployment events with ground stations so we can get telemetry and confirm payload deployment. Just so happens right now that we've got some great views from the Svalbard station as we're over the top, the North Pole, the top of the Earth, if you might say.
OneWeb Alpha 8 and Alpha 4 separation confirmed.
So just 4 remaining OneWeb satellites on today's mission. If you're just joining us, welcome. You came at a great time. We're coming up on the last set of payload deployment events for today's mission. Lifted off about an hour and a half ago from Vandenberg. And you're looking at a live view of the second stage, the top of the second stage at the payload adapter fitting with the last remaining satellites on today's mission.
OneWeb Bravo 7 and Bravo 3 separation confirmed.
Two more successful deployments. Kind of cool seeing the reflection off of that satellite coming back on the adapter fitting. We are in view of the sun. Now, these satellites are quite packaged up right now for deployment, but eventually they will extend their solar arrays and antennas, which you can see on your screen right now.
OneWeb Bravo 6 and Bravo 2 separations confirmed. All Iridium and OneWeb separations confirmed.
And with that, Mission Control said it perfectly. All the satellites have been deployed, including the 5 Iridium satellites during the first sequence, and now all of the 16 OneWeb satellites. So that's going to wrap up our coverage for today's launch. All of us at SpaceX want to give a big thank you to our customers, Iridium and OneWeb, for entrusting us with today's mission. We also got to give a shout out to the Range and the Federal Aviation Administration for supporting today's mission. We thank them for that. And today's launch concludes our 232nd overall mission to date and our 33rd launch of this year. To all our viewers, thanks a bunch for tuning in today, and we'll see you again for our launch real soon.